Okay, today we'll start with generics. Okay, and this was a new feature which was added in Java 1.5. See, there are many new features added in Java 1.5. Many features were added. Okay, but among the many features, 3 were mainly focused towards collections. 3 are mainly targeted towards collections only. Okay, so the 3 things which are introduced in Java 1.5 in focus with the collections were, one is auto boxing. So auto boxing was one of the feature which was added in Java 1.5 for keeping collections in mind. There one more feature which was added was enhanced for loop. Enhanced for loop, or it is also known as for each loop. And the third thing which was added in 1.5 to support collections was generics. These 2 we are covered, auto boxing and enhanced for loop we are covered. So today we will be seeing generics. Understood? So today we will be seeing generics. See, generics is one of the most toughest and challenging subject of Java. Okay, toughest and challenging subject of Java. Many people didn't like it. Okay, many people like it. Irrespective of the fact, generics is there in Java, we have to learn it. Whether you like it or not, you have to learn it now. Understood? And see, even though it's a vast subject, what I'll be doing is I'll be giving you the correct platform so that you will start understanding this. And generics is a subject which is learned with experience. Okay, so we'll set the right platform, and gradually as you go on using and coding it, you'll get the correct picture of what is generics. Okay, it's a vast subject which cannot be concluded in 1 class or 2 classes. It's learned with only what? Experience. But at least we'll learn what is generics, and as we go on learning it, you'll get the correct picture of what is generics and how it is used. So today I'll be teaching you what is generics. Okay, then we'll be seeing how it will be used in programming. Okay, so from the application developer's point of view, how much ever is generics is required, that I'm going to cover now. Means we are application developers. So how much of generics is required for us, for that much I'm going to cover. So once this generics is covered, then I'll use all the 3 and show you how all the 3 provide great support for the collections. So we have learned it individually. We are going to learn generics also now individually. So this we learned individually, this we learned individually, then we are learning generics individually. After we cover generics individually, separately, okay, then I'll be showing you how all the 3 put together give you a excellent support for working with collections. Done? So for understanding, okay, so we'll start off with generics now. See, generics provides type safety, nothing else. Okay, so the main advantage of generics is it provides type safety. So type safety is a terminology. To understand that, you have to see some examples now. Okay, so let's see some examples on generics now. First, straight away we'll move into examples. Okay, so once you see the examples of generics, okay, then you'll start understanding what is type safety and all that. See, before we see again the example of generics, what we'll do now is, we'll see one more example, simple Java example, okay, and then we'll enter generics. That time you'll clearly understand why generics was introduced. So there were some problems existing in the Java language. To overcome those problems only, generics was introduced. Okay, so let us see what were the old problems. Java language means before to Java 1.5, means up to 1.4, 1.0, 1.2, 1.3, 1.4, there was some problem in Java. So to overcome that problem only, generics was introduced. So what is the problem which was existing in up till 1.4? Let's see with an example itself. So you'll have a class called as hide. Okay, so in this class what I'll be doing is, I'll have an instance variable of type object. You understand that? Instance variable of type what? Object. It's an instance variable now. So I want to initialize this. So for initializing this, I have one method. So what will be your parameter? It will be of type objects, and I'll write OB is equal to E. And if I want to get the same object, means I can have the object as same as return type. So what will I have? Return type will be object, M2 method, and I'll return OB. A very simple example now. Okay, so let's see how to use this now. I'll write class. See a non-generics example. So I'll just name the class name as non-generics demo public static void main. Fine. Now see this. See, if I want to work with high class, I'll just create the object. Means I just want to work with this class now. So I'll just say high h is equal to new high. So once I create an object of high, okay, I can call the method. Which method? M1 method I can call. So I call the method h dot m1. But to call the m1 method, what is the argument I have to send? Object. Which object? Any object. Because object is the superclass of any class in Java. So I can send the integer object, or I can send what? String object, any object. Like if I want, I can send now double object, float object, anything. So yes, I'll send now. So I'll send a new integer of 10. This is one way how you can send. But in Java 1.5, autoboxing was introduced. So what I can do is, I can call this method as 10 also. 10 will be autoboxed and sent to M1 method. So M1 is a method now which can accept any object. Yes, fine. So next say, I'll call the M2 method, h dot M2. So what is the return type of M2 now? Object, yes. Very simple. Object O is equal to h dot M2. You know it's object. But if I want to work with the method now, means if I want to work with this value, what I have to do? Typecasting. So generally see how you do the typecasting. If I want to work with the primitive style, I'll write int I is equal to what will I write? Integer. Do the typecasting dot hm2 dot int value. So I have to call the method. Yes or no? Yes. Instead of writing it in 2-3 lines, I wrote it in a single line. Okay, so this is one way. Or other way is, because of autoboxing today, directly I can write what? Int I is equal to integer I can call int h dot m2 and typecast it. The return type directly I can assign it to what? Integer. Fine. So this is one h1 object. Okay, let us name this object as h1. Okay, now what I'll do is I'll go with one more object. High h2 is equal to new high. Fine. Now see, again I'll call the method h2 dot m1, and what is the argument I'll send now? Cluster. Means I can send any argument. Okay, but when I call the M2 method, see this. Again I have to do what? Typecasting. And here, okay, when you're working now, you should be very, very cautious. When you're calling the M2 method now, you should be very cautious in what? Typecasting. Okay, you should know what type of a value it is containing. Based on that, I have to typecast. Supposedly in h.m2, if I typecast to integer, what happens? Class cast exception. Same way, vice versa, if I do it here. If I typecast here in h1.m2, string, what will happen? Class cast exception. So you should be very cautious, and you should know when you're typecasting, you should be extremely cautious, or you have to use the instance of operator. If you either you should know the value or take the chance of what? Instance of. If it is an instance of, means I have to accept the return type as object, then I have to write what? If O instance of string or integer, like that, I have to write else if conditions, and then I have to do the typecasting. So this is one headache process what you are having. But the introduction of generics, let us see what has happened. Understood? So without generics, what is the problem we face? We face compilation problems. Oh, sorry, we'll never face we'll never face compilation problems, but there's a chance that you face runtime problems. Okay, without generics we face runtime problems. Means that will not be, means these things will not be detected. Supposingly if I write int x is equal to, can the compiler detect this? It will not detect. h.m2, I am typecasting what? Integer. But definitely it cannot be casted. And if I try to do this, it will compile. But during runtime you will get the error. And that is runtime exception you will get. That is called as class cast exception. That's a major headache and your program terminates. Let's see how all this can be avoided now. So that is non-generics. Let us see an example for what now? Generics. So see, till now, whatever code you have written, we have written as non-generic classes. So this is the first time we will be seeing how to, or learning how to write a generics class. So it's a new terminology. So we are going to write what now? Generics class. Let's see how to write a generics class now. So you write class hello. Same, everything is same. But only one thing will come now. You will have these angle brackets here. Okay, so this class, this is a syntax. Okay, and this class is called as a generics class, and here you'll specify something called as type parameter. So T is actually called as type parameter. New terminologies just get adjusted now. We are moving into generics now. Understood? So it will take some time for you to get the grip of this subject, as it's a very new introduction. So T is actually called as what now? Type parameter. Okay, so now see, what will I do? So once this T is declared here, okay, this is a type parameter, what I'll do is I'll have a variable of type T now. OB is a variable of type what? T. Just see the output, then you'll get the clear idea about this. Void M1. Okay, so then I'll have something called as T. T is a parameter of type T. Whatever comes, I'll give it to initialize it now. Instance variable I'll initialize. Then return type of M2 will be what? T, and I'll return OB. That's it. This class is called as a generics class. Understood? So let's see now how do you work with this. So class generics demo is the class name I'll give. Class generics demo, public static void main. See this now how you work with this. Clear? Class generics demo 2, because that's the first program. Okay, non-generics demo 1. That will be class generics demo 2. Second example. Fine. Next, see this. When I'm creating the object, I think I'll not have space here. I'll write it below this. Just I'll clear this and write it below. 1 second. Everything is correct. Just I need space. So void M1 you're having T OB is equal to T. Yeah, class non-generics, sorry, generics demo. To now see this public static void main. Yes. See now, this is the syntax now how you'll write. Hello, when you're using a generics class, you have to specify the type. See, this is called as, remember this terminology, because consistently you'll be reading through books and you'll get confused with two terminologies. So always remember, this is called as type parameter. And when you use it here to create the object, it is called as type argument. So you should know what is type parameter and type argument. From here, generic starts. Understood? So you should know what is the terminology, meaning of type parameter. When you define it with the class, it's called as what? Type parameter. And when you give the what type of object you want, means hello should be created with what type of object? Integer type of object, string type of object, that will specify here. So this is called as type argument. Understood? Hello H1. See, everything is same. You know all this. There is no difference. Only extra thing what is coming is this syntax. Till now you are saying hello H1 is equal to null. But now what is coming? That data type, what hello should use, you are specifying it here. So the data type what hello should use, you are specifying it here now. That is called as type argument. Are you clear this terminology now? Very important terminology. This is called as type argument. Okay, so fine now. See now I'll create the object. H1 is equal to new hello, fine. Now when the object of hello is created, H1 can use only string now, because you have specified it what? H1 dot M1, and I can send cluster. Any argument you send. Fine. Now when you call the H1 dot M2 method, you don't have to do any typecasting. Directly you can expect what? String yes. Same way. Okay. I don't have space, but where will I continue? I'll continue it here. So I can write like this also. Hello integer H2 is equal to Okay, new, I can write it in single line only now. Why two lines? Is equal to new hello of, again you have to use angular bracket. That's it. I'm going to type and show it to you. Okay, so that's it now. So what will happen now? h2.m1, what is the argument you have to send? Only integer. You cannot send what? String now. So that is how you are restricting. Okay, so h2.m1 of 10, auto boxing will work. You can use auto boxing, or you have to specify what? New integer of 10. So anyway, generics, auto boxing all come in 1.5. So blindly you can use what now? Auto boxing. Okay, so you don't have to say new integer of 10 and all that. Directly you can say, because anyway generics will work in what? 1.5 only. So you can use it directly. So same way when I say h2.m2, return type is what? Directly I can write int y is equal to h2.m2 directly. So it provides you type safety. And by chance, if you write string s is equal to s1 is equal to h2.m2, you know when is the error reported? Compilation time. So the idea of generics is what? It provides you type safety. Means it will be checking the data type. H1 can use only what? String. H2 can use only integer. Like that it will check. And if you are not using it, it will give you error. At what time? Compilation time. So when you are creating the objects, only you are deciding what type of a data should the class used. Understood? How will you decide? With the help of type argument. You specify the type argument. Once you specify the type argument, now H1 or H2, whatever objects you create, they can use only that particular type now. Understood? So this is how it gives you type safety. Type safety means it checks the data type and reports the error during compilation time. So the errors which were happening at runtime are now being detected at compilation time. Understood? So that's the advantage of using generics now. So there are many advantages, but first advantage is it provides, see the main advantage is type safety only, other than that nothing else. And it brings compilation errors to, it brings runtime errors to compilation time. And also it removes or avoids the class cast exception being created during runtime. It also avoids the class cast exception being created at runtime. So some of the advantages are there. So what I will do is I will type and show you this program now. Okay. So then we will see how to use generics. So this one just a simple demo I have given you. So I will start typing and seeing this program now. Yeah.
Again we have to pass new hello of string, right?
Where?
Yes.
Hello.
H1 is equal to new of it.
Yeah, here no? Yeah, sorry. You have to pass new hello of string. Yeah. Yes, you have to use that. So. Okay. So this is how it's going to work now. So yes, I'll type you this program and show you now. So what we'll do today, I'll create a new workspace today. D drive, Eclipse examples, your month, your batch. Getting it now? My folder, in that Java examples, in that core Java. This is the new workspace I'm creating now. Generics 1.5. Any workspace name you can give. Ideally give the name, same name what you're going to work. So in this workspace, we are going to create some projects. I'll create a new project here, Java project, and the first project I'll name it as 01 simple generics. Yeah, and here I'll have a package now called as com.cluster. Yeah, so I'll go with the first non-generics example now. New class non-generics demo 1. That's the first program. Okay, let us increase the font size. Not apply here. I think it's not increased now. Okay, so the fonts have been increased. Fine, next. So here in this class, what I'll do is, I'll write my class. Hi, the first class which I wrote there on the board. Yes. So here my instance variable will be of type object, the superclass of all classes. Yeah, and next I'll have one method void m1. Object is the parameter I'm having. Next. Yeah, the return type will be object m2 done. So fine, this class is ready now. So let's see how to use this class now. So what I'll do is hi h1 is equal to new hi. Fine. So after creating the object, so I'll call the method now h1 dot m1 and I can pass any argument. So the argument what I'll pass is now a string. Yes, so here you can comment h1 can use any object. Correct now? Okay, fine. Next. So now I'll call the m2 method h1 dot m2. Fine. Yes, but what is the return type? Can I write directly string? I'll get an error. So what should I do? I have to do typecasting. So you have to do typecasting because the return type of that is object. The return type of M2 is object, so I have to do the typecasting. And after doing the typecasting, I can print. Done. See this? We'll run this program. Perfect, nothing wrong. Okay, but as we go on coding, you can see the problems. Next, I'll create one more object. So you have to do, here what you have to do? You have to do typecasting. Fine, next. So what I'll do is, next I'll create one more object, hi, h2 is equal to new hi. And as I told you, see, again, h2 can use any object. Yes, so see this h2 dot m1 and I'll pass, I can use auto boxing, directly I'll pass for 10. Fine. So then after doing it, or you can do like this, okay, first we'll go with this new integer of 10. Later on I'll do auto boxing, but here I'm converting the primitive to object and Because the M1 parameter is of type what? Object. So I have to send argument of type object. So then this is done. So now again what I should do is, see now. Int I is equal to, yes, h dot m2. Can I call the method directly? No. So first what you have to do? Typecasting. Then after typecasting what you have to do? Sorry, h2 dot m2. Okay. See now it works because we are working in Java 1.5. If you are in before 1.5, you have to do what? Again you have to convert the object, unboxing you have to do. You have to do unboxing dot int value method you have to call. Understood? Anyway, I will go with Java 1.5 style only. Directly I will write what? See, this is one option. What you have to do is do type casting and unboxing, or directly you do only typecasting also sufficient nowadays, because Java is supporting what? Implicit boxing and unboxing. Auto unboxing and boxing it will support. So directly do typecasting. That's it here. Int I is equal to integer of h2 dot m2. That is more than sufficient. Okay, now I can print if I want. But you have to take care of so many things here. One is, yeah, see this. Anyway, it works. Now it's not a problem. But the developer has to be too much cautious here. See, in H2 I am putting integer. So when you are calling M2 method, you should be very, very cautious. Yes or no? Yes or no? See, otherwise if I am not cautious, here you have to take take care of everything. Okay. See, by chance, this is okay. Okay. See this now. String z is equal to, if I write h2 dot m2, fine. It will report an error because I am not typecasting, but once I typecast, the error is gone. But when I try to use it, that is when we get the class cast exception. You understood where we get the class cast exception? Now you should be very cautious in using your code now. Okay. So now if the same thing if I try to print, anyway up till there it works. But here value of z is plus z. If I try to print, I'll be getting what? Class cast exception. It's very dangerous. So we want to avoid all this, and we want type safety at compilation time. Okay, we don't want class cast exceptions, and we want type safety to be checked at compilation time. So that is where generics enters. These are the problem developers were facing. So the more problems you face while programming, the better you can understand the language. So if you don't have problems only in coding, then you'll not understand what? Generics also, nothing also. Understood? So you should have problems, means you should understand what is what is that class cast exception, what is that, what do you mean by strict, Java is strictly type check, na? Okay, what argument you pass, what type you receive, what type of a value you give to what type of variable, all should match. Okay, so that is what generics is trying to do now. Let's see how it does it. Okay, so next I'll take one more class now called as what? Generics demo. See the problems how will you solve now? Demo 2 now. Okay. Yeah, here I'll write on class now. Yes. See, this is the first example of generics we are typing. Okay, class hello. Done. This is a very simple class. Nothing wrong in this. Okay. So yes, but this is a non-generics class. If you want a generics class to be written, just use this and specify your type parameter T. Understood? Just write the first program and slowly you'll understand what it is. Understood? Now see, now OB will be of, its OB is a variable and it's of type what? It's an instance variable of type T. Fine. Next, I'll have the same M1 method, void M1, and here what I'll do is, The parameter name I'll take it is T, fine. You can use the type parameter as return type also. Yes, now very interesting. This class is ready now, generics class. Clear? So let's see how you code new syntax. So that's, it just takes time for you to get adjusted, but once you are adjusted, everything will be easier. So then see here, hello. Hello. As soon as I type control space, now see that T will come to specify what type of an argument you want. Type argument you have to specify now. Okay, this is the same syntax you are getting when you are using collections. Remember that. So to understand that, first understand this code now. So I am specifying here, I want to use what? String type. Fine. So once you specify, h1 is equal to null. Fine. So what are you actually doing here? You are declaring a generic, this is called as generic reference variable. Till now I have seen only reference variables, but this is generic all new terminologies just get adjusted. So now very interesting. See, if I say h1.m1, I have to pass what? See, it's clearly prompting now. Pass an object of type what? String. Any other type it will report error at compilation time only now. I'll pass cluster. Anything, but it should be of type string. So now here I'll write the comment. h1 can use only because, why? You should learn the terminology. Type argument is of type string type. Type argument is of string type. Understanding now the terminology? The type argument, this one, this is called as type argument. This is called as type parameter. Understood? So fine, once it is done, next see, this will work. But by chance if I try to say h1.m1 of, okay, new integer of then when is error reported? Compilation time. So it is bringing the problems at compilation time only. Means it is checking the data type what you are using. Earlier it was not checking. Previous program was it checking? It needed an argument of type what? M1 method was needing an argument of type object. But now it is very precise. I want an object of type what? String only. Okay, that is what generics help you to do. Understood? It brings, it reports, means it will check for the data type during what type of a data you are using for h1 object. What type of a data you are using for h1 object? It is checking at compilation time only. Because h1 has been specified to use what? Only string type. So it is checking that and it will not allow you. Understood? So then next, okay. So that it will not allow. Next, if I want to get the value, see this. No type casting required. See the advantage of it now. String yes is equal to h1 dot m2. Done. Over. Directly you are getting what? The value. Even if you try to get off, okay, first let's print this and see. We can create the object. Okay, so you have to create the object. See this, h1 is equal to new hello. Okay, if you say control space, it will only put it. The diamond bracket means angular bracket plus string, it is only putting it. Done. So now, yes, value is cluster. And by chance here, you are calling h1.m2 now. Fine. Now see this. I will say int x is equal to h1.m2. When is error reported? compilation time. Because you have specified it is of type string, so now it is very clear. If you are using h1, it is guaranteed that you are working with only string. Understood? Like that it will help you now. So it helps the developers a lot actually. Fine, next. Not only that, see here. Now don't think this hello object can be used to work with only what? String. But if you want, you can use it with what? Hello. Now I can use it with what? Integer also. Integer h2 is equal to new control space. Automatically it will only put all that. Understood? Then next. Once I do it, now h2 can use only what now? Can use only integer, because type argument is of integer type. Done? If you try to use any other type for h2 now, you'll get the error. See this, h2 dot m1 of what? New integer of 10. Or you can go with auto boxing also, not a problem. This will also work. Understood? Or auto boxing now. Okay, so fine, this also works. Then see now directly int I is equal to what now? h2 dot m2. Very brilliant it is. Done. Understood? So next I can print value of I is okay. So everything works. Here also it works. And by chance if I try to say h2 dot m2 of string, sorry, string z is equal to h2 dot m2, no, it is very clearly telling, see here, control space m2 return type is what? Integer. Very clearly it tells. Yeah. So this is the advantage now. Okay, so now this is how the generics works. Next, see here, one more way I can write the code. See here, till now when you are creating the hello object, I was using the generic support of the class by sending what? Type argument. But if you are interested, use the type argument. Else, don't use it. See, you can create an object like this also. Hello. See, this is what you are doing when you are typing the collections. You are removing this, yes or no? Fine. h3 is equal to new hello. Still it works. But here, means see, the class is generics. This class is a generics class, but I am not using the generic support of it. Understood? So when you do not use the generic support of it, this h3 is called as raw type. Now let's see again, the problems with raw type continues. Like how the problems without generics was there, same problems will continue. Let's see the problems with raw type. So using raw type without generics means no need of, if you want the raw type, no need of specifying the type argument. Done. So then the problem with this is raw type does not check for type safety. Same way. Earlier how it was working, like that only it will work. It will treat. See this, what happens. See h3 dot m1. Now I can pass any object. Any object I want. It's not telling me string or integer this time, m1. So I can pass any object. So what I'll do is, I'll pass something like new integer of anything you can pass. New integer of 10. Then again I'll say, if you want you can do like this. See, it's not restricting. Compiler is not checking it all this time. Again, if I want, I can say h3 dot m1 of what? I'll pass some string value. It is allowing both. Whichever one you want, you pass. And here, see this. When I say h3 dot m2 now, the return type is object. Means you have to do the typecasting. Okay, and I have to be very cautious now. I should know h3 is using which object, whether it is using integer object or string object. And one miscalculation here will give me class cast exception again during runtime. So that's the problem now. So I should be very cautious. So string s1, yeah, because it's of type string, I'm doing it. Okay, but you have to do typecasting. So raw types, okay, will not provide type safety. You know what is a raw type now? When you are using the generics class without the generic support, or when you are not specifying the type argument. When not specifying the type argument, okay, it loses type safety. Raw type always lose type safety, or they do not provide type safety. Understood? Yes, again it works. This is not a problem, but again you should be very cautious here. If I, yeah, see this will work, but fine. But by chance, I'll comment this now. And in h3, what object I got now? Integer. I commented. String I commented. Now in h3, I'm having what? Integer. But I'm typecasting to what? String. So I'll have what? Problem now. Value of so I'm trying to print the value. Class cast exception will occur. Getting it now? So fine. So this is how the generics starts off. Okay. Now we'll see some notes on generics. Say 1 second. Yeah. We'll see the actually yeah. So this is how the generics is working now. Some more things we'll see on generics now. What we'll do is we'll see the which one. See, this is how your source code looks. This is how your source code looks. Yes or no? When you are working with generics, this is how it's looking now. Okay. Let us see in the dot class file what has happened, because you have to understand one more terminology here called as type erasure. This terminology you have to understand. Okay, whatever argument type you are specifying your argument type argument here now, string, integer, all that will be erased when? During compilation time. Whatever things you are saying, it is only in the source code and it helps the developer, but everything will be erased in the compilation time, and in dot class file you will not see this. So let's see the dot class file how it looks now. So you can decompile it. You know how to find the dot class file now? Right click, okay, go to the dot class file, properties, go to the location where your project is there. See, this is where your project is, yes or no? Yeah, in core Java, in generics 1.5, this is the project. In project, you have got bin and src. Src will contain what? Source code. Bin will contain dot class. Go there. Yes. So in hello dot class, let's see what has happened. Open with Kavaje. See, this is how hello dot class is looking now. You wrote T, but it has been erased. The type parameter is erased. See, this is how your source code looks. Are you clear with your source code? But what has happened after compilation in the dot class file? This is how, means earlier we are writing code like this now, same way it is generating. Okay, then next let's see what is the compiler doing now. It will read everything and it will generate its own dot class file. Now see, if I'll open the dot class file of generics demo.class. Open with any decompiler. See there, h.m1, fine. See, when you're calling m2 method, see here also, it's not specifying any type argument. Type argument is also erased. Type parameter is erased. Type argument is erased. Okay, the process of removing the type parameter is called as what? Type means it's erasure. Anyway, the notes is there. Just 1 second. The process of removing generic type information is called erasure. The process of removing generic type information is called as erasure, and it is done by the compiler during compilation time. Okay, so see this, even here in which one? You can see the two dot class files we are having. One is hello.class, the other one is what? Means in your Java file, how many classes are there? Those many dot class files will be present now. So and in generics demo also, that is here, M2 method. Am I typecasting here in M2? Am I typecasting? But who is doing the typecasting? It will be done implicitly. So that is the best part now. It will do accurate typecasting. It knows what is H1. It knows what is H2. So based on that it will do typecasting. Understood? So compiler will generate this code, and finally this is the code which will be used during runtime. Understood? So this is very important thing what you have to understand. So in fact whatever feature means generics feature you are using, it is only present at what? In the source code. It is not present in bytecode. Okay, it will be erased. So that's why that process is called as erasure. Okay, fine now. So these many things we have covered. Let's see some notes on generics now. So what is generics now? See, generics is a new feature which was added in Java 1.5. The benefit of generics, it provides type safety. The main advantage of generics are, see, it helps in doing type checking at compilation time. It will check the data type h1.m1. Integer means integer only. So it checks the data type you are using at compilation time. Next, no need of typecasting because it will be done what? Implicitly. Who will do the typecasting? Compiler. Understood? So then converts runtime errors to compile time errors and avoids what? Class cast exception. These are the three benefits you have seen till now. One more advantage is with generics. When we use generics with methods, when you use it, I will be showing you, it simplifies method overloading. Okay, means a single method with a common logic can be used by many data types in a type safe manner. So that's what I told you. See, this is how the generics begins. Okay, but as you go on working with generics, you'll start understanding the advantages of it, benefits of it. This is the introduction to generics. Clear? Fine. Some more points now. See, a class which has a parameter, type parameter is called what? Generics class. And this is how the syntax is there now. Class name, type parameter list. Okay, till now I am using only one type parameter. I'll show you how to use more type parameters now. Understood? So anyway, the type parameter list. This is the syntax. Class name, type parameter list. Okay. Then next, how do you create an object of it? 1 second. Yeah. Let me bring it into single screen. Yeah. See this. Class type parameters list. Then here, when you're creating the object, how you do? Class name, type argument list. Right now you have used one. If you want, you can have more. I'll show you. Reference variable is equal to new class name, type argument list. And if you are having constructor, you have to pass the constructor argument list also. Still now our constructors, we are using default constructors. If your constructor is having any arguments, you have to pass that also. That's how you do it. But actually this is how it was working in 1.5 and 1.6. But later on, in 1.7 they have modified. You don't have to specify the type argument list in 1.7 onwards. They made it simple now. Understood? Means when you are creating the object, see, this is how you will do it in what? Right now it will give me error because I am using what? 1.6. So see this. This is how you will be doing it in 1.7. That's all the change. Now it gives me error because we are using 1.6 compiler. So you don't have to specify the type argument here. You don't have to specify the type argument. It will be taken implicitly. Understood? Whatever type you are specifying it here, earlier you have to specify it both sides. But now it will be taken implicitly. Understood? And this is called as diamond operator. So that is a new introduction in Java 1.7. What is a new thing in Java 1.7? The introduction of diamond operator. It is used to, again, they are giving a simplified approach to use what? Generics. That's it. Understood? So now it will give me error because we are using 1.6. Fine. So anyway, I given you that also. Syntax for creating an instance of a generic class in Java 1.7. How will you do it? Class name, type argument list, everything same. Reference variable is equal to new class name. This is the diamond operator. Are you following now? It is empty here, so it's called as diamond operator. Constructor argument list. Done? Okay. So this is how we work with generic classes. You define it and then you create objects and start using it. Fine. Next. Yes, this is one more crucial thing what you have to understand. When creating an instance of a generic class, the type argument must be of type what? Class type only, and you cannot use primitive types. Be careful with this. Okay, means when creating an instance of a generic class, the type argument what you are going to use, this is the type argument now. Okay, must be of class type and not primitive type. Okay, so valid because type argument is class type. H1, H2 are valid, but H3 is invalid because I am using the primitive type. And lastly, the process of removing generic type information is called erasure. It is done by the compiler during compilation time. Done? Yes. So now see, till now we are saying our class type parameter was only one. But if you want, you can specify any number of type parameters for your class. Any number. So just I'll show you one more generic class with two type parameters. Okay. Let's see how you do it now. Generics demo 3 I am naming. Fine. So this is a valid class. If I want, this is a normal class now. This is a normal class or a non-generic class. If you want to make it as a generic class, what will you do now? You will specify the angle brackets here and specify the type parameters. How many type parameters you want? T and comma V. Okay. Done. First I'll use this, then I'll show you, then we'll discuss what it is and all that. Understood? So first we'll get the output. So but just you have to understand now, my class is now having two type parameters. If you want, you can continue more. T, V, X, anything like that, you can go on giving. So anyway, just see this. T, OB1. Yes, OB1 is a variable of type T. V, OB2. So OB2 is a variable of type V. Done. So what I'll do is I'll have one constructor now this time. Very interesting now. See this constructor. Right click. Using those two, I'll generate the constructor. Fine. Yeah, your constructor type, your parameters can also be of type what? Generic type. Fine. Next, I'll have only two getter methods. I'll not have setter because anyway we're going to initialize them with what? Constructor. Okay. So I'll go with source. You can go with some getter methods. Select getters. So we'll have only what? Getters I'll have return OB1, OB2. Your code is ready now. Understood? So next, we'll see how to work with this. What is the name again? Sample. Okay. See this sample. Sorry, control space. So it says use type parameter. Understood? So what is the type parameter I'll use? I can use anything now. But first I'll go with to string. String S1 is equal to new sample. So everything will come up automatically now. So here you have to specify what? The arguments. What argument? This is the argument constructor argument list now. The constructor requires an argument of type what? Whatever your specified here. Whatever you have specified here for T and V, T is what? String. So here also it should be of type what? String only. So I'll give the value. What value will I give? I can give it as something like hello fine, valid. So what is the syntax now? When you are creating the object of generic class name, type argument list, yes or no? This is, see, this is class name, this is type argument list, this is reference variable, this is new class name, again type argument list, then constructor argument list. If you want, you can refer to the syntax, you just now wrote it. Understood? So then next, once it is done, see now bindas you can work, no need of typecasting. A is equal to s1 dot get which one? Object 1. Both return string. S2 is equal to B I'll take. S1 dot get OB2. Yes. So here in this example, what you are saying, one class can have, a generic class can have two type parameters. So when you want to create an object of this class now, you have to use two type arguments. Again, not only that, see here, sample. Okay, I'll go with now integer. S2 is equal to new. Then auto boxing I'll go. Valid now. Done. Next, int x is equal to s2 dot get ob1. What is the return type? Integer. Directly you'll get, you don't have typecasting. Int y is equal to s2 dot get ob2. Done. And if you want, you can print value of x and y is. Still fine. So now S1 will work with two string objects, S2 will work with two integer objects. Done. So you can go with the combination of string and integer also, nothing bad. See this, sample. So first one will be integer. And the second one will be string. Fine, not a problem. First one is integer now, and second one I'll give the value of cluster. One string value I'll give. Done. So S3 dot get ob1. What is the return type? Integer. Directly I can accept it. Get ob2. Perfectly it will work. Done. Okay. So understand working with, see, we very rarely write generic classes, that you understand. We very rarely write generic classes. I'm not saying you'll never write, you'll write, okay, but very rarely you write. This is how you write a generic class, but we maximum use what? Generic classes. So all the classes which are in collections are what? Generic classes. So that is why get comfortable with the syntax of using it, because maximum we go on using generic classes. Rather than writing generic classes, we go on to use generic classes. Understood? So tomorrow when I use generics with collections, it will become dead easy for you. So you don't have to worry too much. Understood? So this is how it works. Yeah? So yes. Now coming to the topic of writing generics classes. I told very rarely you write. Okay. But if at all you write, let us see what is this T and V. Okay. Is it that you have to use T only? Is it that you have to use V only? No rules like that. You can use anything. Okay. But Java has some conventions. Generally say for variables. Okay. Java says use what? Camel casing. First letter. See, this is the convention what we follow. If you want to declare an employee ID of type int, so the convention what we follow is int. I'll declare. Okay. Prefix will be int. Okay. And I'll say employee ID. This is how the convention we follow. There are some conventions what we follow. Means we go with camel casing. Small letter, first letter is small. Second word, first letter, caps. Third word, first letter, caps, like this. Supposingly if it is an string. Naming conventions I'm telling. Okay. Or okay. This is how you go with variables. Okay. And how do you go with the class? First letter, caps. Means class, hello. How do you go with the method? Okay. Void, save, employee. First letter small. Second word, first letter, caps. So for class name we have convention. For method names we have convention. Okay. So for everything we have a convention here. Similarly, when you are writing your type parameters, you can give any name. Okay. Instead of TV, I could have told what? Hello, world also I could have written. Okay. Anything I could have given. But the convention what we follow is we don't use such big names. We use single letter. That's the convention what we follow. We follow conventions. Okay. So we use a single letter, and that letter should be caps. You can use anything. You can use X, you can use Y, you can use Z, anything in the world you can use. Okay, you want me to change it to what? X and Y? Fine, see this. Alt Shift. See, if you want to change any variable name, just click Alt Shift R. Okay, and change it to X. Still it works. So you can use any name here, X and Y. So the type parameter is what now? X and Y. So everything works, there's no harm. Okay, it's not that you have to use TV, anything like that. But it should be generally use single letter, understanding now? Single letter, and it is in caps we use. Okay, and one more thing what happens is when we are writing our generic classes, the common convention what we follow is T only. That's the common convention we follow. Okay, and after that we can go with V, U, anything you can go. T, V, X, Y, anything you can go. But in collection classes, what those people are using means if it is a class related to collection, they use something called as E. E means element. This is the convention they are following. For our classes, you can use anything. Okay, means but generally we use T for our classes. Means general classes, I am telling. General classes, we use the type parameter as, it should be single letter, remember that, T. After T, if there are more, you can go U, V, X, Y, anything you can use. A, B also you can use. Okay, but the Java people, when they are writing collection classes, they have followed a convention. Understood? For collection classes, they are using E. I show you the documents now, Java docs or API docs, you'll understand. Okay. And for maps, they have used, map will have what? Two type parameters now. For maps, they have two type parameters. They are using K, V. Means K is for key, V is for value. When I start using, you'll understand it very clearly. So this is the convention what we follow, nothing else. Clear this? Okay. So this is, see, general classes, anything you can use, T, V, U, V, X, Y, A, B, but generally, okay, and collection classes E they are using, and map classes they are using K and V. So anyway, tomorrow I'll be showing you how to use, means in the next class we'll be seeing how to use collections with generics. That time you'll get a clear grip of how to use collections with generics. Okay, so we'll continue with some more examples now. I just have opened the Java docs for you. You can see this now. See, for they are using what? This is a generics class now, which an array list is a generics class. See a public class array list E they are telling. E means element. Understood? Something, their convention what they are following. Then next, in add method what you are doing? Whatever you create now. You can see like this. Next class we'll be seeing this. Array list string AL or list is equal to new array list of what? String. Finish now. Now array list will contain what? Only strings. So earlier your array list was allowing all types of objects, but if you want to restrict that it should allow only strings, you can restrict it today. But earlier there was no restriction. Understood? Earlier there was no restriction. Okay, so just sample I'll show you, but in depth we'll be seeing in, I think tomorrow only we'll be seeing this, or in the next class only we'll be seeing this, because now I don't want to mix it up. It will deviate now towards collections. Okay, but anyway, this is the idea now. Array list string AL is equal to new array list of angular bracket string. Try this today. AL dot add of string, it will allow A, but if you try to add AL dot add of 10, error when it is reported, compilation time. That is the actual reason why generics was invented. They wanted to give type safety to collections. Earlier your collections were not type safe. Once you create an object of collection, no, any object has set or which one, array list, linked list, they are storing dissimilar data. There is not a provision for you to stop that. Okay, so that's the reason they introduced this. Anyway, we'll see it in the next class. Just this is simple. I just made you understand how to refer to the document now. Are you following now? And this whole concept we'll be seeing it in the next session. So E, see here. And one more advantage now. Try this today. AL dot get. Return type till now was what? Object. Get of say second. Get me the second element. Return type was what? Object. But now blindly you can use what? String. This is the advantage. So no type casting, and whatever you are adding into collection is checked during compilation time. Understood? So that's what I told you. Generics in one class you will not get the grip. As you go on using it, you'll start getting the grip of generics. So try these two methods today, three methods, so that in the next session it will become easy for you. That's it. Yeah? Okay, we'll come back to generics now. Put the next heading, bounded type parameters. Okay, bounded type parameters. Still now, see, you are specifying the type parameter and you can pass anything as a type argument, no? Yes or no? You can pass anything as type argument. You cannot restrict. See here. So in the first example, in this generics, okay, hello, T can be what? Anything. In the next example with generics, which I wrote, T and V can be what? Anything. It can be string or integer or anything, but it should be of type class type. Okay, but I want to restrict that it should allow this set of classes. Understood? Or this particular classes only. You can restrict it. Generics gives you a support for that also. So that is where bounded types will come into bounded type parameters. You'll bound means it should be allowing only these type. You are binding it now, and will not allow any other type arguments. So just you can write some notes on this. I'll come back and explain you this points now. Okay, and for this I'm not going to type now. These examples are ready. I'll just execute and show it to you. You can only follow it now. It's very simple now. The project name you can create. See, this is a ready project. I'm just showing you how to import projects and use now. Just copied and pasted the project. So what will I do here? Import existing projects. Yes, browse. You have to select. It is already selected. Okay. See, now it is selected. Copy projects into workspace. Anyway, I have copied. So copy projects into workspace. Finish. It will come now. So there are some projects here. This is a project, and there are some examples here. There are 3 examples, but I have kept the 3 examples in different packages. One example is for one package is for one example. So first we are going with bounded type. See, there are 3 classes now: A, B, C. Simple. A class is there, B class is there, C class is there, and they are related classes. A is there, B is there, C is there. They are related. How they are related? Simple hierarchy, man. Class A, void method is there one, show one. SOP inside A, show one. Now class B extends A, void show 2. It's a different method. SOP inside B, show 2. Class C is extending what? B. Fine. Void show 3. SOP inside C, show 3 method. That's it. Very simple class. Nothing else is there. Okay. Now see, class sample is there. I want to restrict it to use only what? Classes of A, B, C. That's it. So that's when we say class T extends A. Shall I clear what I have written? Simple class, but keep this. Okay. Same simple class, but it can use what? It's a generic class. But whatever T you are going to use, it should be extending what? Compulsory? A type. So you are binding now. Okay, it's bound. It's called as upper bound. Upper bound means A or any subclass of A. Any subclass means up till A, not more than A. Means I cannot bound what? Object. Because superclass of A is what? Object. I'll make you understand what is that upper bound. Understood? So up till A is the limit. Up till A you can bound. Okay. So this is the limit now. Okay. So this is how you specify. Everything is same. Now sample class can use only what? A, B, C. That's it. Now see this. Sample A. And here I am using again same thing. Constructor. Get OB method. Nothing else. Sample A. S1 is equal to new sample of A. A is what? Our class. Type argument should be what? Class type. Till now you are using type argument as built-in type. But I can use type argument as what? User defined type also. But end of the day it should be a class type. That's the example. Understood now? Till now string and integer were what? Built-in classes. Now class A is what? User defined. Yes, your type argument can be any class type. That's the reason I am setting this example now. Clear? So fine, A. Then next, S1 dot get OB. Guaranteed that it is A. Same way. And I can call which method? Show one method. Same way here I can call what? B. Guaranteed that it is of type B, I can call both the methods. S2 dot get OB. It's of type B, I can call both the methods. No need of typecasting. Okay. Generally, why do you typecast? To access the subclass members. No, directly you are getting of type B, directly you are getting of type C. Understood? So you will not have any problem only. And it will execute now. Everything works fine. Okay. Means I have called the methods from every object. A also, B also, C also. Fine. But see now, this time, earlier you are creating a sample with which object? String. Try to do it. Upper bound. It will not allow you. So it is checked at compilation time. You are restricted. Okay, you are restricting the type parameter. Okay, so it's a bounded type parameter. You understanding what is bounded type parameter? When you are specifying a type parameter, you will bound it to some limit. Means these classes and this set of classes. So that's what is called as bounded type parameter. Next, one more thing what you have to understand here is a bounded type parameter. Yeah, I'll say sample extends, T extends what? B. I can bound like this also. Now only what? B and subclasses of B. B and subclasses of B means C I can use, but not upper class. You are bound with what? B. Anything which is up till B. Upper bound it is called. Upper means up till B. Understood? And now see the error. A is giving you error. Understood? So this is called as upper bound. So many times you will be coming across the syntax. So be careful with this. Okay. As you use, you will understand. Clear? So I'll bring it back to what? A itself. So as soon as I make it to A, that error vanishes. Yeah. So if you want the code to write, you are getting it now. Do I have to write it? Getting it now. So this is how you can restrict your arguments, type arguments. To restrict the type arguments, we use bounded type parameters. To restrict the type arguments, we use bounded type parameters. Yes, some notes you can see now. Bounded type parameters are used for what? If you have written it down, you can check out. It's used for restricting the type arguments. When we are writing a generic class, we can restrict the type argument that can be passed to the type parameter. When specifying a bounded type parameter, we use upper bound. Okay. Then when a bounded type parameter is specified for a generic class, then the type argument used should either be the specified superclass or its subclass. Done? That example is for this itself now. Okay. Next we'll see one more topic. Wildcard arguments. Okay. So wildcard arguments. See, these are all new terminology. Okay. Just get used to it now. See, program is same. There is no change. A, B, C, sample class, everything is same. Only thing what I will be showing you is now, I will use sample as an argument now in another method. Everything is same. What will be the program now? A, B, C same, sample same class. You know, we can send your user defined data type as arguments now. That only I am showing you now. So okay, if you are good in core Java, all this is very simple, man. Okay, so this is done now. So we are going with wildcard arguments. Just write these notes. Okay, I will show you an example and then we can understand what these points are. Simple points are there. Okay, see this. So I'll go with the next example now. Yeah, this example now, wildcard is present in which package? com.cluster.wildcard. Go there. See, A, B, C, same sample. Yes. Now hello class is having some methods M1, M2 and M3 method. Yeah, this is the hello class for you. Okay, this is an M1 method. See now, this M1 will accept sample object with anything. Means your sample object can be created with what now? A class, B class, C class. Only these three. But again, see, here I am having a sample as a argument now. This is one thing what will take time for you to get adjusted. So I am trying to show you how to use generic classes as arguments. You have seen how to use normal classes as arguments. Now we are seeing how to use generic classes as arguments. So that is only the concept here, nothing more. See, sample question mark T means here you can send an object of any type of sample. This is a wildcard. That question mark what you are seeing here is called as the wildcard, or sometimes it's also known as, it's called as a wildcard. Okay, here any sample object, it can be of type A, it can be of type B, or it can be of type C. Here sample object should be what? Any sample object, but it should be A, B or C. Here also, this and this almost all same. But here your sample object should be what? Sorry, here extends, this is upper bound, but not above A. But not above A. Extends me. If you want upper bound, use extends keyword. This is a very important interview question. Okay. If you want upper bound, what do you do? For in generics, we use extends keyword. Understood? If you want lower bound, we use super keyword. It's the next one now. Very simple. Ulta it will become, and that's it. Okay. See, anything up till A is fine here. Here, lower bound means B and above B. Understood? Super of B. Think like that. Super of B. Extends means subclass below. Okay. Upper bound means you'll use extends keyword. Okay, behavior is up till the superclass and its subclass. Up till the superclass and its, that means that is the upper bound. That is the upper limit. Understood? Up till the upper class, till the superclass and its subclass. Lower bound means from here, see, B means B is bound now. You cannot go below B. You cannot go below B. Whatever it is, it should be above B only. That's it. Okay. So A is, so this is how you are using it as parameter. This is one thing what you have to understand, because this is the common syntax what you will be seeing in what? Java docs. Upper bound, lower bound, that here, and gradually you will get adjusted, because I told you very rarely we write which one? Generic classes. We use more of generic classes. Okay. So fine, now see this sample A, one object, sample B, S1, S2, S3. Now for M1 method, I can send any H object now. Means I can send S1 also, I can send S2 also, or I can send S3 also for M1 method. Okay. But for M2, yes, it is upper bound. Anything which extends A I can send. But for M3, only AB means superclass of B. This will work. Just see this. If I say extends here also B, what happens now? This will go wrong. Extends B, I am telling now. Only B and C will be allowed now, not A, because upper bound is what? B. Understood? So then that is one thing what it will take time for you to just get adjusted. After that it will be simple. This is the last part of generics what you have to understand. Clear? So that's how it works. So rest all is same now. There is nothing big here. So only one class comes extra here, which is called as class hello, just to show you how to use the sample method as arguments. Done now? So and this is what is wildcards now. Wildcard arguments are used when you are specifying a parameter or a return type for a method. Return type I have not shown you, I will show you. Okay. There are three types of wildcard arguments: upper bound, lower bound and unbounded. Upper bound is supported with extends keyword and lower bound is supported with super. That's more than sufficient. Clear? Go through this example also. And lastly, we are having one simple method here. See here, this is also same three classes A, B, C. Now hello class. For M1 I want it to restrict only of this T should be of type what? T, there I am going to you send now for M1 as an argument I can restrict what? Anything but subclass of A. Again it is what? Upper bound. Anything but upper class. So like this you can specify. Yep. So then that's it. I think it will not be used for specifying a parameter, I think. Yeah, return type also fine. Fine, you get the idea of it. Fine then, that's it. So this is about generics now. So, and generic method demo. See this, if I am sending h.m1, now look at this hello class. When I am calling m1 method, I should send what? Only an object of type A, but not of type string and integer. You have restricted it to be of type only either A or B or C. That's it. Extensive. Okay, T extensive. So this is an example for see what you have to understand is this hello is not a generic class. Hello is not a generic class, but M1 is a generic method. So sometimes classes will not be generic, methods will be generic. That you have to understand. Understood? Classes will not be generic. Is hello a generic class? See, none of the classes are generic class here. A, B, C, as well as what? Hello is a generic class. But M1 method has been made as generic method. So sometimes classes will not be generic, but methods will be made generic. Understood? This also will be understanding. And say this, if I try to pass one string argument, error. Done? Even if I try to pass this one, it will give me error. Clear? I think it will be used only for specifying a parameter. Remove the return type. And you are specifying a parameter for a method. Yeah, that's one mistake. Just rectify it. Clear with this? So that's all about generics. And yeah, when we use generics with collections, that time you'll understand the importance of why generics was introduced. Done now? Okay, that's it for the day.